Hello, everyone, and welcome to the Midweek program at the J.C. Raulston Arboretum. My name is Blake, and I'm the education assistant here at the Arboretum. And today we are in, well, this part of the garden doesn't really have a name. We're tucked behind the fantasy circle and behind this giant Tonkin wingnut back here, surrounded by a bunch of snowdrops and interspecific hybrids of hellebores, because those interspecific hybrids of hellebores were more than likely propagated by tissue culture, what with them being sterile. And today we've got a program for you today for Gardening 101. We are doing Tissue Culture 101. We have Lis Meyer over here, who is the plant propagation professor at NC State, who's gonna learn us a little something about tissue culture. And we are joined by our nursery technician, Sophia McCusker, mostly for emotional support and good times, but she is bound to give us some good stuff too. Those of you joining us on YouTube, feel free to like this video, subscribe to our channel, and leave a comment down below. And with the announcements out of the way, I think we can pass things over to Lis and Sophia to teach us about tissue culture.
Sweet.
It's funny, we're grafting deciduous conifers in my class that same week.
That's hilarious.
Is coming. It's just the time.
No kidding. It's a good time to do it. Yeah.
Tis the season to graft.
It is.
We'll jump in because when I first asked Lis, I just thought of this. When I first asked Lis to do this, she was like, how am I going to do 101? There is nothing 101 about tissue culture.
I don't remember saying it, but sure, that sounds right. Yeah,
but I was like, okay, just 101 for tissue culture. So I'll let you.
We can do that.
We can do it. We got it. We got it. We got props. We got it.
All right. Yeah. So like Blake said, I do teach plant propagation at NC State. So this is something we do in my class every semester. And Sophia and Blake both did it in my class at some point in their college careers.
Oh, in the distant future, the faraway future.
So
past.
long ago. You can't even
Yeah,
remember
for sure.
it, right?
I don't know.
Time's not even real, so yeah, mix it up as much as you want.
Yeah, distant future past.
It's all the same.
Yeah.
But it is one of the more advanced techniques that they learn, and there's some special equipment that we use. And you may hear me call it tissue culture, or I might call it micropropagation, but it's basically, I'm talking about the same thing. Basically, we're talking about taking a small piece of a plant and putting it in a sterile environment in a lab. And then from there, we can do a lot of different things. So we can mass produce plants in ways that we can really bulk up our numbers faster than we can with other means of propagation. You can establish virus-free stock plants. So this is something we do a lot with some of the food crops that are popular in North Carolina. But it's a powerful tool, and it allows us to do a lot of things. And as Blake mentioned with the hellebores, even the hellebores that aren't sterile, there's really not a ton of good ways to mass produce hellebores. They're slow growing. The ones that are fertile, you can use seed, but with seed, there's always going to be a good amount of variation in the seedlings. So you can't keep all of the exact same traits about that plant that you like, which I don't know what the key traits of shooting star are. I'm guessing one of them is the flowers tend to point upwards more.
For sure,
than an average hellebore. But you have seeds, and then you can just do classic division where you cut the plant up, and that's pretty much it. There's not a good way to propagate them by cuttings or some of the means we would normally mass produce the plant. So most of your cultivars of hellebores, if it's not like a seed mix or a seed strain, did start off in tissue culture. My class works with something a bit easier because hellebores are difficult and slow. But the process is similar in that basically, and here's one of, we just did these this week. So this is Venus flytraps in the jar there. But in a sterile environment, they are placing the plants into a synthetic media. And it's really just fancy Jell-O, because in that media, which is exactly the consistency of Jell-O, are things like sugar and the regular nutrients that you would put in a fertilizer, so nitrogen and phosphorus, all of that. And for the Venus flytraps, it literally comes just like Jell-O in a packet with the powder. You just add it to hot water and let it cool. But we do have to make sure everything is sterile, because if we don't, we get this. Oh, it's so gross. You had to open it, didn't you?
I did, because we got to see what's inside.
Oh, it's nasty. So
you gotta get real.
That's all just fungal growth, maybe some bacteria, and as gross as that looks, that just came from the regular air in the classroom where I teach class every day.
This is what we're breathing.
It's fine. Close it up. But those things grow so much faster than the plants that if your culture gets contaminated, they're going to kill your plant pretty quickly. It just disturbs me a lot.
Yeah, it is. It's pretty gross.
Yeah. So the question being, how do we keep everything clean, right? This is where the special equipment comes in. So first, when we're making the media, we have to sterilize it in an autoclave. Sophia is going to be like...
Vanna White.
Yeah. This is an autoclave. Ooh. It's really just a fancy pressure cooker. So it sterilizes using heat and high pressure.
But does this have a yogurt button like my Instant Pot?
I mean, it has a lot of cycles, so maybe. I feel like you can do it if you wanted to.
Okay.
Now I'm just thinking about yogurt. I can't. So we sterilize the jars and the media in them. We just autoclave the whole jar minus the plant, just like this, so that when it's done, everything inside is sterile. Sometimes we'll use Petri dishes. So this is one from my class too. In that case, we sterilize it in like a big flask, and then we dispense it into the Petri dish in a sterile environment. So we have the autoclave.
Why is that one black?
Hold on, I don't want to go there yet.
Okay.
Well, no, I will. It's black because it has activated charcoal in it, which is another common ingredient for tissue culture media. And these are orchid seeds that are growing in here. You cannot see them yet, but they will happen. And that part I'll talk about later. All right. So we autoclave everything. And then while we're working, so my students this week, they all had a jar with a clump of Venus flytraps about that size in it at the beginning of class. And all I needed them to do for that is to just cut it into smaller clumps and put it in a new jar. So they're using forceps and scalpels for this, and those have to stay sterile as well. And there's a number of tools you can use for that. You can use a flame alcohol lamp that's basically invisible fire that can easily tip over in the hood. And I don't think I can live the rest of my career doing that with students every semester. So I use a mini incinerator, which is what is in the picture there. It gets 800 degrees Celsius inside that. So it really does incinerate.
I was thinking that I should suggest to bring this because if you spray alcohol into it,
it does become a mini flamethrower. So you should not do that.
Because I've never done it. I never did it by accident in class. It's never happened.
It's never happened.
But in theory, it could.
It could happen. You have to be cautious. It's very hot and you shouldn't touch it. But we stick the scalpels and the forceps in there, and that just helps sterilize them before they get used on the plant tissue. Of course, you have to let them cool off a little bit after that. So we have the autoclave, we have the mini incinerator, and then the entire process is taking place in what we call a laminar flow hood. And it's a sterile workbench. So we'll diagram it. Sophia asked me if I had a diagram today, and I said, no, I just usually draw it. And so she printed a diagram because I'm a terrible drawer. You should think of it as a three-sided, well, almost like a cubicle, right? So the user is going to be sitting here where these arrows are pointing. And what happens is air from the room gets sucked in, usually from the top or sometimes from the bottom. And it passes through two sets of filters. And one is just like the air filter in your HVAC system at home. It filters out dust and larger particles. I buy them at Lis for the ones that we have in the lab. The second one is a HEPA filter, and it's a very powerful HEPA filter, very high grade. And it's going to remove smaller particles, especially things like fungal spores. So the air from the room, which has all this in it, is going to go through through the 2 sets of filters, and then it's blowing a constant flow of sterile air out towards the user. So you have sterile air across your workspace, and air from the room cannot enter because of the positive pressure. So my students and I will sit here, and as long as we're working inside that workbench, everything remains clean. Right? It's not as easy as it sounds. You've got to constantly be thinking about what you have and haven't touched and try not to contaminate things.
Everything is dirty.
Everything is dirty.
So you have to touch. What always caught me up, I went and helped Liz move stuff last summer, and what caught me up was touching, what was I was touching.
Did you touch the paper plates?
I touched the paper plates. I touched my hand to something, and then
you don't even have to touch something directly. If your hand touches something and then the plant material touches that, then it's probably contaminated. We usually work on sterilized paper plates, which I also autoclave. And so I'll tell the students, they're working, and I tell them, don't rest your tools on the paper plate because the tools have been in your hands. And as soon as you set them down on the paper plate, now that part of the paper plate is also contaminated. So it takes some practice. And I always tell them, I learned how to do this, in plant propagation when I was a student from Dr. Denny Werner. And then I did it in graduate school as well. And probably the first whole quarter of pages of data from graduate school was just contaminated, because it's a practice thing. But if you're successful, so again, this is the ones that my students did this past week. In about 4 to 5 weeks, it'll have multiplied from this size to this size, which, especially for Venus flytraps, is pretty quick. And the secret to that is that in addition to the sugar and the nutrients and all those things that we put in that media, we also put plant hormones, depending on what we want to form. So this one is in a media with a plant hormone called cytokinin, and it just helps this multiply and make lots more leaves and stems or shoots, right? So we do this to really bulk up our shoots. And then once we've done that, we may move it to a new media that has auxin in it, which is the same plant hormone you would use on the base of a cutting to get it to root. So this is some hostas from one of my colleagues' classes. If you look at the bottom of that jar, you can see it's rooted quite well. Once it's rooted in, you can actually then go ahead and move the plant out of culture into still a sheltered environment, right? Because this plant it has no stress. It doesn't have to.
It's living the dream.
Yeah, it's living the dream. Everything it needs is there. It doesn't really have to photosynthesize at full force because there's sugar in the media. There's no water stress. It's a perfect closed environment. It's actually anatomically different than a regular plant when it grows in here. And then when you move it out into the greenhouse, it'll form new leaves and become more like a regular plant. So
how is it different?
You want to go there?
Cliff notes.
Actually, so you can see one of the things that's different about it here. If you look closely at those roots, you'll notice they don't have a lot of branching and they don't have root hairs. And root hairs are what take up most of the water for plants. So until this forms new roots outside of the tissue culture environment, it won't take up water as effectively as a normal plant. They also will have less of the waxy cuticle on the leaf that helps reduce water loss. It just won't be present on these. And even the pores that release water in the bottom of the leaf, the stomata, those will be stuck open because they've never really had to function. So until this forms new leaves outside the tissue culture environment, it'll be this sort of weaker version of itself. And then eventually it will grow new structures and they will be normal. So normally we put these under mist in the greenhouse for at least 2 weeks so they can kind of adjust before we put them out into the cold, real world.
Mm-hmm.
Yep. So that's the basics of it. And the multiplication stage is the key for, as far as commercial production goes, of being able to really bulk up quickly, something like, for example, the hellebores. Exponential growth or exponential spread is a phrase that you heard a lot during the pandemic. And that it's the same thing. Because if I have this little bit and every 4 or 5 weeks it gets this big, and then I keep separating them out and separating them out, I can end up with millions of plants in a matter of months just through that exponential growth of the plant. And that's just because of that plant hormone that we add to the media. There are a lot of other applications of tissue culture. The orchid seeds, which my students sowed orchid seeds in these Petri dishes this week as well. And one of the reasons you can't see them is they just did it, and they're very small, like dust.
Tissue culture is the reason that orchids are so widely available now, isn't it?
Yes. So orchids used to be more of a high status symbol, which I guess some of them still kind of are, but it used to be a lot harder to get a hold of orchids because, again, a lot of them grow slowly, and there's not a lot of really good ways to propagate them in mass. But by tissue culture, and normally for commercial purposes, they're not using the seeds, they're using small shoots. They can make them much more readily available because they can make so many more, so much more quickly. And that's why you can get a moth orchid at Trader Joe's or, yeah.
For $20.
I feel like that tells a lot about our shopping habits right there. I've gotten one for $10.
That one was probably wilted in the back, though.
Yeah, it was. Anyways, we do the seeds, which normally you're not going to do orchid seeds unless you're an orchid breeder.
I wish I'd remembered because I have some of the seeds. I have some seedlings you gave me from last year.
Nice.
Yep, and they're nice little, I mean, they're in probably 2-inch pots now.
Excellent.
Had I thought about it, I would have brought them up.
I already gave all mine away, and the rest are dead, so.
I'll take any more you have.
I should have some more this time. But they're so tiny, the seeds, that in nature, they usually have like a relationship with a fungus, a symbiotic relationship that helps them germinate. But usually that's not available to us in cultivation. So if you want them to germinate, it has to be in tissue culture. And that sugar in the media is basically taking the place of the fungus. It's still really slow. So probably by the end of the semester, my students will just start to see some tiny little green seedlings on those plates. It'll probably take a full year for us to go from seed to a, 2-inch pot, 3-inch pot?
I've got mine are in 2-inch. The ones you gave me are in 2-inch pots. And
Yeah.
I think those were from the spring.
That checks out.
Maybe?
Yeah.
Yeah.
So that would be like a year.
A full year.
Yeah. So it's not quick, but.
And those were Blatilla.
Oh, yeah. The Blatilla are faster.
Yeah.
We did this again this year.
Nice.
So it depends on the type of orchid, too, of course.
Watch out for the Blatillas.
Yeah. They're going to take over.
So we did have somebody ask a question, how much or what part of the plant do you need to use for tissue culture?
That's a really good question. For the how much, theoretically, you only need a single cell. Now, to get a single cell off is not very feasible, so. But you don't need much because am I going to use my favorite word? Are we doing this?
Please do it.
Oh, yeah. Do it. Do it. I was waiting. It already was in my head. I was like, the answer is...
I've brainwashed you both.
The answer is...
No doubt.
Every cell in the plant has all the genetic material it needs to make a whole new plant. And that's called totipotency.
Oh, I thought it was going to be it depends.
No.
Oh, no.
That's another one.
Yeah.
Well, it does depend. That is going to be the what part.
Yeah, but I knew it was
Hold on to
totipotency
that.
because I remembered Liz's DJ name is DJ Totipotency because of her totally
about that.
potent beats.
So for your next party, are you on Instagram?
No.
And you call yourself a DJ.
I have only do that at select weddings that have been here, actually.
Super exclusive.
Super exclusive. I'm not a professional at that.
We
Okay.
only need.
We are
man.
digressing.
We need to get on this. We could go.
But so totipotency.
Right, totipotency. All the cells have everything they need to make a whole new plant. So you don't need any more than a single cell, but
In theory.
practically that's not happening. So usually we just usually have a small clump. I've done it before with some plants where you're using a piece of the leaf and it's maybe like a millimeter square or something like that. It depends. There we go. It depends on the plant.
There we go. For pines, you need like tips of
The little-
the candles.
Oh, okay.
Maybe I don't know.
I don't know. I don't do this. But yeah. Sophia is referencing the fact that every time students ask me a question in class, I always just say, well, it depends. And as far as the part of the plant you use, that's going to depend on the plant.
That was the next question.
Yeah.
Does it vary from plant to plant?
Yes, yes. So for commercial production, most of the time they're using the meristem, the growing point at the very tip of the shoot. That's the most common thing that they would use, but different plants, you can use different parts of the plant, and it kind of depends what your goal is as well.
Are there any plants that you cannot propagate with tissue culture?
In theory, the answer should be no. In practice, yes. In
practice, we probably just haven't figured out how to.
Right, that's it. A whole year and a half of my graduate program involved attempting to tissue culture some things that we never succeeded. And I was about to say, to this day, no one has succeeded at it, but actually I met someone at a conference and she had done it and she gave a talk about it, and I scared her because at the end I was like, hey, and she's like, who are you? I'm like, I told her who I was, and she's like, aha, I read your paper. Because no one works with these plants. And I was like,
do you remember what plant it was?
I do. It was...
Please tell us.
It was so Tom Rainey was my grad school advisor, and he's released it now as, it's the Shimlinia, Shimalima Ding Dong.
Oh, yeah.
Oh, yeah. Which I said, that's the name you went with? And he just chuckled. But it's an intergeneric hybrid between the Franklin tree, which is extinct in the wild, and Shima, which is one of its Asian relatives that is resistant to Phytophthora root rot. So Shimlinia is a hybrid of that. And yeah, I never got it to work. But this lady at the conference, whose name escapes me, but she's at University of Georgia, she achieved it. She had been doing tissue culture since the 80s.
Oh, wow.
She was a master. So, yeah, mostly it's just we don't know how to yet, but there's no reason why it shouldn't work for all plants. And there's a lot of research on that still.
Yeah. And here's a quick question. Someone says, so these plants are then identical to each other, so they're clones?
Yes, unless you're like with the orchids, because these are from seed, the ones that my class did, those won't be, but everything else will. Because it's really just like taking a cutting, but on a very small scale and with a little bit of extra help on the multiplication part.
Cool beans. So somebody did ask a question about the HEPA filters that you use. Do you know what size you use of those?
Let me think. They span the whole size of the hood, so it depends on what size hood you have. And mine is a 6-foot wide hood.
Do you mean like the filter?
The particle size?
I assume so.
That part I don't know.
Sure.
Because basically, the way I know about them is that we had a hood where the HEPA filter was starting to leak.
Ooh.
And so that was another semester where everybody's stuff got contaminated.
Oh, you haven't told them about the main story.
I mean, you didn't bring it up yet, but we have someone that comes out and inspects those for us, and he replaced it for me, so I'm not really sure. So I can tell you how much it cost if you want to know.
Yeah.
It was $1,000, so I know it must be a very small size.
No kidding.
But yeah.
Well, Jane just put in a comment. She says most TC hoods use 0.22 micrometer filters.
There we go. There we go.
Honestly.
It's pretty small.
That is pretty small. I would like, so you remember, you probably do because you taught me this, but so with the cotton candy grapes with like embryo rescue, is there any way you could try and maybe weave that tale for us here now?
That was going to be my question too, along with the...
Okay.
Go ahead. Go with it.
Sophia has a story that she would like to share from her time as my student too, but...
No, it's fine. I'll
do Blake first. So, yeah, one of the applications, so like I said, it's a powerful tool. There's a lot of applications. And one of those is used when you're breeding plants that, well, in the case of seedless grapes, they're not producing seeds. So if you're a plant breeder, right, and it's for most of the seedless grapes, it's a single gene mutation for stenospermocarpy. You remember that one?
I don't, as a matter of fact.
I like that one.
Which is just that the embryo starts to form after the plant is fertilized, but then it aborts before it can become a viable seed. And since you're actually breeding to select for that, that causes a problem, because then how do you grow on what you just made the cross for, right? And so this is where embryo rescue comes in. And embryo rescue is used in a lot of different scenarios, but basically what you're doing is you're going in, so you cross your two parent plants that you want to combine traits of, and that embryo begins to form. And then you have to remove it from that developing ovary before it aborts and place it into tissue culture. And if you do that, then it will continue to live and grow and become a new plant. And that's how you can recover your seedless grape hybrid. So the cotton candy grapes and a lot of those newer seedless grape varieties that are out, it's the Moondrop is one.
Oh, wow.
Honeydew, a lot of them are out now. And they do tend to cost a little more, but part of the reason for that is to develop those, they had to go through this whole fairly complex and expensive process to even get there. Now, once you've got the grape that you want, the seedless grape you want, you can just, do cuttings and normal propagation means. But in those first few steps where you're trying to breed something new, you're going to need that embryo rescue if you're doing something like seedless grapes.
So would that apply to when you're breeding for sterility in other cases?
Often, yes.
Okay.
Not always. It depends. But
Nice.
Often, yes.
Are we getting a load of...
Maybe. What was your question that you wanted to ask, Liz? What was the
I didn't
She
have a
just wants
question.
to share some things that she learned as my student.
Yeah?
It depends, and a couple drops make a difference.
Sophia, I'll tell it.
Yeah.
Sophia would like to share that.
I only remember tween 20, and that you, at the beginning of the semester, Liz was like, I ran out of this, so we're going to try it without it. But when I was mixing media, we didn't have it. And it's only a couple drops, so does it really matter?
2 drops per liter. Because we were doing the orchid seeds, and the way we do it, you can just take the whole pod, sterilize the outside, and then as long as you cut it open in culture in the flow hood, it's fine. But I usually have about 50 or so students a semester, and I don't have that many orchid seed pods. So we have to open it ahead of time and dispense the seeds, which means we then have to sterilize the seeds before they go in here. And so the sterilization solution, and again, this is one of those things that varies based on the crop and what part of the plant you're using. But for these orchid seeds, it was 5% Clorox, 5% of 70% ethanol, and 2 drops per liter of something called tween 20, which is just a surfactant that helps those sterilizing things permeate the tiny microscopic nooks and crannies of the seeds. And I could not find it that day, and I was in a hurry, so I left it out, and I thought it'll be fine. It was not fine. So Sophia's entire class's orchid seeds were contaminated, and I'll never be allowed to forget that until I die. But you will never forget what tween 20 does till you die. So
Oh, I forgot what it did. I just remembered it because I thought it was funny.
don't do that to me. Don't take my win.
The tween 20? I could find
important.
out. I could find out what it is.
I just told you. You don't even listen.
It's a surfactant. Now I remember again.
Good job.
I'll probably remember
Beautiful.
Yeah.
Okay, so
now. Yeah,
Mark,
just use some dish soap.
Mark had a
Probably
question.
can.
He wants to know if the added plant hormones are consumed during culture and if you have to add more hormone during that process.
That's a good question, too. So they are consumed by the plant tissues during culture and basically used up. So I can tell you right now, actually, so this is a fresh jar of media that my students I made the media 2 weeks ago, and the students put the plants in there this past week. There's probably still plenty of the plant hormone in this media. This one was done in September, and you can almost kind of, if you're watching it over a long period of time, you can kind of see the point at which that hormone has been basically used up by the plant, because initially it multiplied very quickly, right? Those first few weeks, by like week 5, it was already this size. But it hasn't really grown much since then because it's basically used it all up, which is why we have to do, if we want to keep that multiplication process going, what we call a transfer, which is what my students did. So they cut off new clumps from existing plants in the jars and transferred to new media with new hormone in it so that they can multiply again. So yeah, it does get used up.
Can you talk about where these are stored during, like,
Yes.
where do we put these? We just put these in direct sun and let them.
It's better not to, although I do give Isaac one and he puts it on his windowsill every year and then it eventually dies.
That's filtered.
Because it's too bright. Yeah, so we put these just on, I have a set of metal shelves in the classroom and they just have lights on them, regular lights like you would use as grow lights for any kind of plants. I have them on a timer, so it's 16 hours of light a day, but that will vary depending on the plant. And for most plants, that's enough. There are some plants that require to be kept at a certain temperature as well while they're in culture. So for example, I did for a while work on a project for tissue culturing some hellebore cultivars that there's not really anybody tissue culturing them in the US. And so what I read was that they needed to stay at a cooler temperature, like around 60 degrees Fahrenheit. So the nursery I was working with, we started looking at growth chambers because you can buy a growth chamber that has lighting and temperature control, but they were quite expensive and we didn't need a very large range of temperatures. So they definitely retrofitted a wine cooler and put lights in it, and it was at 60, and that's what we put those cultures in. But the vast majority of the plants that I've done tissue culture with don't require it. There are some cases where you'll want to keep them in the dark, so they'll produce a bunch of callus tissue first, which is just a bunch of sort of unspecialized cells that will turn into other structures later. But most things just on a shelf with some grow lights, that'll do it.
Here's a fun question. Have you ever looked for any epigenetic changes with different additives to the media?
Yes.
Yeah?
That was a lot of my thesis work.
Sure.
Was that I did not have a lot of success.
Okay.
I shouldn't say that I didn't have much success. I did eventually. It's just, it took me a while to get there.
Okay.
Tom might watch this. Maybe not. So this is a lot of the research that you will find on tissue culture because, for example, with the different plant hormones, auxin is a class of hormones, and then there are different chemicals that all are types of auxin. So different plants will respond differently based on the type of auxin or the concentration of auxin. A lot of what tissue culture is used for as well is, it's a really strong tool for plant breeding, right? So let's say that you can't get the effect or the traits that you want from more traditional breeding methods. One thing you can do is just by growing them in culture alone, because of the very fast growth rate, you'll sometimes see unusual things happening, and even things as extreme as polyploids forming. So just doubling the entire genetic content. There will be a level of that just occasionally, and that's what happened in my research from them growing here. But often you will do that intentionally if you're a plant breeder to try to get some sort of phenotypic expression that will be something that we might desire. And you'll find that a lot, especially in some of the, for hostas, actually, hosta breeding. They do a lot of tissue culture, and some of the really wild-looking hosta cultivars that you find out there, that's how they started out.
No kidding. Okay, well, there is a question here that somebody asked only because you brought up Blatilla striata, and I think it's an appropriate one for you to answer, Sophia. So Vandy says that her Blatilla striatas had about 8 seed pods, capsules, fruit. They have opened up now, but she never saw anything that she recognized as seeds. So she wants to know if it's worth her time to try and harvest next year, when, how, and then what do you do?
I feel like this is a test.
Yeah, no kidding. Honestly.
If they're open, probably it's too late.
Right, yeah.
But you want to harvest green pods.
Yeah.
And the easiest, like we said, Plotilla, Liz does in tissue culture. I don't know. Do they seed out? I don't know if they seed in the garden.
Honestly.
I don't think they do.
They do, but not as much, not as successfully, right? And unless you were like eagle eye watching it every day, it probably had seeds, but they are like dust. So they just probably blew away on the wind and you didn't even notice. But Sophia's right. Once it's open, they're gone pretty much. You don't have to, that's one that actually, it will germinate on its own here, just not very much. Whereas when we do it in tissue culture, usually the whole petri dish will just be full of seedlings. So it's a lot easier to do that way. Yeah.
They look like crabgrass. That's what I remember.
They do
I almost
like it.
It was very tempting to try to weed them.
I think I did weed some out once because we had put them in the flats in the greenhouse and they were so small I thought they were weeds, and then I realized what they were because I forgot.
Oopsies.
Sometimes we make mistakes.
Sure.
And that's how we learn.
Okie dokie. Russell wants to know, if we want to try tissue culture, where do we look up the needed details for the plants that we want to do it with? Are there any recommended sources for supplies and any recommended written explanations of technique?
Yes.
Yes.
Okay, so there's one book that I really like called Plants from Test Tubes. And it's not necessarily about doing tissue culture at home, but it has a lot of details about tissue culturing specific plants, and it has a lot of good basic information about the techniques. And it also has in there a table that kind of tells you, if you want to start up your own tissue culture lab, what you'll need and kind of what the expenses will be, which is very useful. I have actually the hellebore project that I mentioned, which that was in conjunction with Pine Knot Farms. I didn't really have time to keep that up and also teach. So I passed that off to two students that have graduated now, and they actually run a small tissue culture lab out of one of their living rooms.
Oh, wow.
It's totally normal.
It's totally normal. It's actually looks very good. And they've got the hellebores successfully cultured in there, I think. But yeah, they use a pressure cooker instead of an autoclave.
And just an Instant Pot.
Yeah,
Shake.
kind of.
Watch for Instant Pot sales, and then just get
Yeah,
'em,
that's
'cause
right.
Yeah, completely contained.
They told us, wait till after Christmas when people return the ones they don't want to the thrift store, and then they go get them. For their containers that they grow the plants in, I think they get some at like a restaurant supply company that has them for very inexpensive. The media components are pretty basic and easy to, I mean, sugar is sugar. But they buy...
It's dangerous. That's it.
Yeah.
That's dangerous.
I just mean the sugar that you eat at the grocery store is not a whole lot different than the science sugar you buy from a chemical supply company. In fact, the kind at the grocery store is more pure because it has to pass FDA for eating.
That's hilarious.
That's what we used up at the mountains. We just got it at Ingles. But yeah, so the supplies are easy to get. The one thing they did shell out for was a laminar flow hood.
Okay.
The ones that we use at school on campus in the classroom are very large and expensive. They're usually around 10 to 15,000. They got a small desktop one for, I think, somewhere around 1,500 to 2,000.
Okay.
But if you poke around on, say, well, just on social media in general, maybe Reddit, you'll find where people have kind of built their own. And so it's doable, right? Because it's just filters.
Sure.
I visited, it was a mushroom production place where they had sort of built one for, which mushrooms are easier because they grow faster.
Yeah.
But they had basically just a whole room that they did the culture in, and they had the filtration for the whole room. It was a very small room. And they had antibacterial paint on the walls, which I did not know was a thing.
No kidding.
So there's a lot of ways you can do it. If you have the actual flow hood, you'll have a higher chance of success, but there are ways around it. I know one of my colleagues, Lee Ivy, told me he used to teach it at a school where they did not have the flow hoods, And so they just had sort of a clean box that they sprayed copiously with 70% ethanol.
Whoa.
And he said, we had about 10% success. And I was like, well,
Okay.
It's not zero.
That is not zero.
But we usually have a lot better success than that when I don't forget to add key ingredients to stuff.
For sure. We had somebody come give a talk for the North American Rock Garden Society about doing tissue culture. I don't remember who it was, but they said they learned about it in a country where people were just doing it in their kitchens. And they, like, it was around where orchids are native. And like a lot of people were just like growing orchids from tissue culture in their kitchen. You can find that video somewhere on our YouTube channel. I will leave a link in the description when I post this for sure. So,
well, and I think, at least from what I've seen, there's a ton of, like, as far as research goes, a vast amount of that coming out of places like India, because, like you said, a lot of the plants that we would be wanting to culture are from there. And I think, people have just been doing it for quite a long time in an unofficial context. So
for sure.
And now in an official context.
Well, and different things, like you don't have your Rudbeckia today, but the Rudbeckia is one that you like because it can outcompete a lot of the contamination.
Huh.
So that I wonder if that's
really interesting.
That's true. If it's a fast enough growing plant. So I did used to, they died. That's why I don't have this. It's during the pandemic.
We weren't allowed on campus.
I wasn't allowed on campus. They died. We had Rudbeckia or black-eyed seasoning culture, which is something you don't need to tissue culture those to grow them. There's a million easier ways to do it. But we had some up at the mountain station for breeding purposes. And they grow so quickly that even if there's a little bit of contamination, it'll usually be fine. Which, if you're teaching that in class, is a nice feature, so that your students can have more success. And also, they would actually go all the way to blooming in the jar sometimes, which was pretty adorable.
That's hilarious. Jennifer would like to know if you have room in your courses for non-students.
So I can't. I wish I could. And that's because they're degree courses at NC State. So you have to enroll through the university for it.
You have to also pass a series of trials to get in.
Oh, yeah.
Like, you can't just get in when you want.
That's not true.
Liz has to vet you. And then if you're not correct, she says, next year.
This is lies, but it is usually full because it's required for all horticulture majors and minors. So if you're like a freshman trying to get in, you usually can't because the seats are usually full.
Okay.
A series of trials.
So no battery of riddles, but bureaucratic red tape.
Yeah.
Okay.
It's out of my control.
Okay.
It is very full all the time.
Yeah.
No worries. Well, that looks like that is all of the questions that we have in the chat. Was there anything else we wanted to talk about? I don't think so. I think this was a wonderful program. For a Tissue Culture 101, I think we hit everything that everybody needed to hear. And
we went beyond 101 a little
honestly,
there.
Yeah, for sure. If we go any further, people's heads will start to explode. And we don't want that.
Mine might.
Yeah, honestly, for sure. But thank you so much for coming out for this, Liz. We really appreciate it. This was a lot of fun, really. And thank you, Sophia, for joining us and helping make it fun. Yeah. Definitely.
I made it happen. I reminded Liz. I was like,
good job.
No kidding. Teamwork makes the dream work.
That's right.
Awesome.
That's right.
And thank you, everybody, for joining us for this program today. We will be back next Wednesday at 3 o'clock. Tim Alderton will be going over spring ephemerals, which will be very exciting. I hope you will join us for that. We will see you all then. Y'all take care.